one carbon chain. Came from methane. Drop the E, add Al. Remember a while ago with the alcohols I said it was OL? Now you have to be careful that I can tell the difference between your A's and your O's. So it's methanol. Longest hydrocarbon chain, this is automatically the one carbon. Take the longest stem, minus the final E, plus Al. Frequently you'll see it written like that. So this would be 1, 2, 3, 4. Then it's dichloral. And then 4 carbon chain, butane, butanol. Notice you can start putting double bonds in here also, and that will make it more complex. You have E and E, and that's where you want to break it up and start putting in your different numbers. Okay. Is this an optical isomer? Or does it have an optical isomer? Yes. 1, 2, 3, 4 different groups. This is a whole group on here. So there's my center of asymmetry, or my chiral carbon. Those are 2 alternate names that they use. And we want to show that there was an optical isomer. So there's your mirror image. I guess I went. Yeah, I did it. Okay. What else can we do with it? What's good?
How come the plural is it 1, 2?
What?
How come the plural is it
Whoops.
1, 2?
It's because this is automatically the number 1 carbon. You have to start numbering here, so it's 1, 2, 3, 4.
Okay.
The aldehyde carbon takes precedence. Notice one of the reasons of putting in these sequences, if you have mixtures of these different functional groups, last one, it's called higher, it has a higher hierarchy, is the one that's determined in using the word name, or the one that determines the word ending for the molecule. So it's just higher order. As I said, I'm going to mostly steer away. I'm not going to give you a lot of things with 5 or 6 different functional groups in them, but in the real world, you encounter these things. So that was the aldehyde. This, by the way, has the common name formaldehyde. It's the primary ingredient that they use when they pickle. They used to dissect pigs. I guess they do cats now. I don't know. Maybe cats. I don't know. But that's the formalin thing, that's the primary ingredient, that's in the preservative there. And one of the reasons they did the first remodel of this building, that's hazardous to your health. And the students were always out in the balcony because they didn't have any good hood systems down at the first floor. You don't see people out in the balconies anymore dissecting, so they do have hoods where they can do their dissections. But that was the reason they had to remodel the building. Okay. So that's the form. That's the common name. I wouldn't worry about that too much, unless somebody said what's formaldehyde, you know, because a lot of you will encounter that somewhere in your careers. Okay, then I want to get to ketones. And the first simplest member of the ketone family. Common name dimethyl ketone. But this would be propane, and you drop the final E and add O-N-E. Now there's only one thing you can do with that, so it's redundant to say 2-propanone, but our big bottles of reagents say 2-propanone. That's the only place you can have the O-N-E carbon, or carbonyl carbon is on the second carbon. But this has a much more common name. And we still use this quite frequently when we're cleaning glassware and things because it removes grease and it dries nice and quickly and gives you a relatively grease-free glass surface. So the common name is acetone. The IUPAC name is propanone. This would be pentane. 1, 2, 3, 4, 5. And again, modern things would say pentanate. Easier to write it than to say it. What else can I do with these? I can put other constituents on here. Notice this will not ever be an asymmetric carbon because of the double bond. Anytime you have a double bond, it can't be an asymmetric carbon. So it's the longest stem again. And by the way, some years I mark that wrong, some years I don't. So, yeah, you don't want to depend on what kind of mood I'm in, so you always want to spell it correctly. And you don't have to worry whether I'm in a good mood or not. Okay. I'm trying to decide when to take a break in here. Why don't I take a break right now? Because everybody seems to be needing a break. So we'll take about a 15-minute break. And that way I can go for another, well, that's 2 hours. And I'm going to go a little bit quicker. I'm going to oxidize my aldehyde. And you say, how the heck can I oxidize that? I'm going to put an OH on here again. And you say, oh, I recognize that from Chem 1A. What is that? Carboxylic acid group. It's not an alcohol, it's not a ketone. These two things together make the carboxylic acid. That's your organic acid. Okay. So the simplest member, 1 carbon chain, and here we start getting into 2 words now. Take methane, and you add OIC acid, methanoic acid. This has the common name formic acid. When an ant bites you and you get the sting, it's because it injects you with a little bit of formic acid. I think form came from Latin word for ants or something like that. That's my famous brother-in-law joke. brother-in-law always kept saying, I smell ants. He was really smelling this, but I don't know why he was smelling ants in the first place. Probably needed a job. Okay, going back to this thing. Going back to this thing, methanoic acid. The next member up. Ethanoic acid, and this has a common name, used it a lot. Notice the ACT is another way of referring to a 2-carbon chain. So that's acetic acid, but the IUPAC name would be ethanoic acid. This automatically is the number 1 carbon. The carbonyl containing carbon is the number 1. The chain goes back this way. There used to be another way of doing this with alpha, beta, gamma going down the chain. We're not going to use that, but you see it. It refers to, again, this being the 1 carbon, this would be the alpha carbon. So when you oxidize an aldehyde, you get a carboxylic acid. The other thing that's functionally isomeric, the ester. Okay. Now notice up here there's an ether, here's an ester, and this thing, you don't have to depend on whether I'm a good mood or a bad mood. That's always wrong because that's somebody's name, right? So people, students try to outsmart me. They figure if I'll do this, and it's supposed to be this, he'll give me credit. Supposed to be this, he'll give me credit because I can't spell, but I mark it wrong either way. So this is always wrong. Ketone, sometimes it's a mood, and ignore the Y, other times not. But this I'm always in. So I'm going to talk about esters. Now I'm ready to take a break because I have to do a chemical reaction to talk about esters. Now we'll take our 10. Bye.